Hey everyone, I want to help you correct your formative by showing you and going over the answers. How to find the answers. Alright, so a solution to a system, remember, is the ordered pair that the two equations have in common. So it's an ordered pair that makes both true, or it's an ordered pair that is on both of the lines. So this first question, this is your minimal question. All you need to do is find where the two lines intersect, and that ordered pair is your solution. So in this case, we have to go over 3 and down 2, and that's a solution. For this equation, let me show you again. For these two equations, these two lines are exactly parallel. They could go on and on and on forever and ever and ever and ever, and they would never have a point in common like this one. So in this case, we say there is no solution, or none. And the third one, again, the only point that these two lines have in common is this one right here. So I like circling it where they intersect, and I find that ordered pair. So I have to go over 1 and up 3 to get to that ordered pair. Remember, and you might see this on the summative, if you have two lines that two equations that when you graph them, they're exactly the same line, we say that there are many solutions. Another minimal or basic question is just deciding if an ordered pair is indeed a solution to a system. All you have to do here, as some of you said in class, is take the x and put it in for x and the y and put it in for y to both of them, and if you get yeses for both, then it's a yes for the whole system. So what that would look like is, for this equation, y is 2 equals 2 times x is 6 plus 3. So does 2 equal 2 times x plus 3? Well, 2 times x is 12 plus 3 is 15, so that does not make a true statement. Since we had one no, it's a no. If both of these turned out to be yes, it would have been a yes. But the whole point is that you're taking the y and plugging it in for y. And we'll do this one, the second one, in a different color. So y was 2 equals negative 3 times x we think might be 6 plus 2. Negative 3 times 6 is negative 18 plus 2. That's a negative 16. That was also a no. But again, if you had two yeses, it would be a yes over here. Alright, solving systems by graphing. You guys were so good at graphing when it was just one equation by pulling out the m and the b. Remember, the b is the one without the x. It's your beginning. And the m is how you're going to move. It's your slope, so 2. So I'm going to start that first equation, the first equation I'm doing in red, at 3 on the y-axis. So again, we're going to start at 3 on the y-axis because b is the y-intercept. The beginning is y-intercept. And then the slope is 2. And when the slope, I'll write this down here, when the slope is 2, remember, if there's not a numerator and a denominator, we have to open it up. So that means a positive 2, so to get to the next point, we have to go up 2 and over 1. Up 2 over 1, or we could reverse the signs for both of them. Down 2, back 1, down 2, back 1. And try to make a straight line. You will have an easier time because you have a ruler. Alright, so now the second one, we're going to do the same thing. We're going to pull out the m and the b. B is the beginning, or the y-intercept. M is how you move, or the slope. So it is 1 and 1. The one without the x is your b. The one with the x is your m. And since there isn't anything in front of the x, we know it's going to be 1. Now again, you should be correcting this with me. When I see your paper, I would like to see everything that I write down on your paper too. So if you have to go back and fix some things like up here where you didn't show work, please do that. The only way you're going to get this is if you actually do the work. All right, so now we're going to start graphing with this one. I'm going to start on the y-axis, my beginning. Right here, my beginning is 1 on the y-axis. So I'm going to go up to 1 and put a point. And then I move, it is a positive 1. And since it doesn't have a denominator, we're going to slam a 1 down there. So the rise is 1 and the run is 1. Rise 1, run 1, rise 1, run 1. Or we could reverse both signs. Negative 1, negative 1. So we could go down 1, back 1, down 1, back 1, down 1, back 1. And try your very best to get that straight line like that. And remember what the solution is. The solution is that point that both lines have in common. So right there. So to get to that point, we would have to go back 2, down 1. So negative 2, negative 1. And we can certainly plug those numbers back in to make sure that we graphed it correctly. So I'm going to take this, change the color to purple, and I'm going to take both of these equations down here. Y equals 2x plus 3. So I'm going to plug my negative 1 in for y and my negative 2 in for x. So now to simplify, I have 2 times negative 2 is negative 4 plus 3. That does equal negative 1, so that one is a check. And then I'm going to do my second equation, y equals x plus 1. I'm going to plug that negative 1 in for the y and the negative 2 in for the x. Negative 1 does equal negative 2 plus 1, so that one checks out. So we know that this is the solution to our system. We did it correctly. All right, for the next two problems, it just says to solve algebraically. You can either use substitution from a few days ago or elimination. I can tell you that this one is best to use substitution because the y's are already, the equations are already solved for y. So this is like when I helped some of you, I talked about how we popped off the y key. We can't use y anymore, but we do know what it means. It means 3x. So it's where you're putting both of these. So you're taking this and putting it in for y. So 3x equals negative 2x plus 10. And then you're going to solve that equation. So you're going to add 2x to both sides to get 5x equals 10 and divide by 5. So x is 2. So that is the first part of my solution. Now I have to come back to one of these original, and I'm just going to use the first one. Y equals 3 times, now we think that x is 2, so y equals 6. So that would be the second part of my solution. I always like to check, so I'm going to take my y equals 3x, and I'm going to plug in the 6 for the y and the 2 for the x. That makes a true statement. And then I'll do the other equation, y equals negative 2x plus 10. So we think y is 6 equals negative 2 times x is 2 plus 10. So this is negative 4 plus 10 is 6, so that checks out as well. So I know that this is a true solution. All right, so that is that problem. For question 5, I would not use substitution because I don't have a variable that is all by itself on a side. But I do have right here 2 coefficients that are opposites. So this is like we were learning the combination or elimination, where we can add the two together. So 7x plus a negative 7x cancels out. 2y plus y equals 3y. A common mistake that I've seen you guys make is thinking that you're subtracting this. You're not. You're adding them together. So some of you on this part right here had y, but it's really 3y. And then I'm going to continue adding down. 11 plus 16 is 27, and then I can solve for y. Y is going to be 27 divided by 3, which is 9. Now I can plug this number back into either one of these. So I'm going to do 7x plus 2 times 9 equals 11. 7x plus 18 equals 11. So I'm going to subtract 18 from both sides to get 7x equals negative 7, and divide by 7 to get x equals negative 1. I want to remind you one more time, you are supposed to be doing this along with me, so feel free to pause and don't just copy what I'm writing, but really think about why I'm doing this. You have a summative in a couple days on this, and you need to know how to do it. So my x is negative 1, and my y is 9, and I can plug that back in over here. So negative 7 plus 18 is a positive 11, and 7 plus 9 is 16. So both work out. This is my answer. All right, for the word problems, you really have to figure out what it is that you need to write for the equations. Let's look at the problem. One snowman is 100 centimeters tall and is melting at a rate of 2 centimeters per minute. So I see right there that I have my beginning and I have my rate of change. Another snowman is 50 centimeters and is melting at 1 centimeter per minute. So again, I have my original and my rate of change. After how many minutes will the snowmen be at the same height? And what height are they the same? Okay, so first I like to say what my x and my y is. So my x is going to be the number of minutes, and my y is going to be the height. So the first snowman, his height, or her height, I guess it's his, is 100 centimeters minus 2 centimeters for every minute, where the second snowman starts at 50 centimeters and is melting at 1 centimeter per minute. So here is my system. So I'm going to now insert this. Remember that y key is broke, so I'm going to replace the y with that expression. So 100 minus 2x equals 50 minus 1x. So then I'm going to start solving this equation. I like getting rid of the variable that is the least, so negative 2 is less than negative 1, so I'm going to add 2x to both sides. So this is, after this, it's just straight, simply solving equations. So is negative 1 plus 2 is 1. I have to subtract 50. So x is 50. Now this says hours here. I'm assuming that it's supposed to say minutes. But if you said 5/6 of an hour, that would be actually more accurate than if you just said 50 minutes given that label. All right, now from here, we have to plug it back in to find y. So I don't care which one you use. So y equals 100 minus 2 times 50. 100 times 100 is 0. So they're actually going to be the same when there's 0 centimeters left. So when they're completely melted, they'll be the same height, and it's going to take about 50 minutes. All right, and question 4 is actually a 4-level question. It's saying, at the store, Anna buys 2 pens and a notebook for $6 total, and Aaron 1 pen and 2 notebooks for $12 total. How much is each pen and how much is each notebook? So again, I like saying what my x and my y equals. So my x and my y, what we're looking for is the cost of each pen and the cost of each notebook. So I'm going to say the x is the cost of a pen and the y is the cost of a notebook. So now what do I know? That 2 pens, and sometimes it helps to write the variables right in there. I'm going to make that a different color. So my pens are x's and my notebooks are my y's. So x and y. So if we take 2 at however much they cost plus 1 at however much the notebook costs, it costs $6. So 2x plus y equals 6, and x plus 2y equals 12. And there's a few different ways that you could solve this. One way is to solve for one of the variables, either the y or the x, and use substitution. So I could subtract x from both sides, 2x from both sides. So now this equation right here would be y equals 6 minus 2x. And now I can pretend that the y key is broken, and I'm going to take this and plug it right in. So x plus 2 times 6 minus 2x equals 12. Now again, this is the 4-level for this one. It won't be the 4-level for the summative. So again, all I did was I solved for y so I could use substitution. And I substituted in that new expression right here, in for this y. So right there. Now I'm going to use the distributive property. X plus 12 minus 4x equals 12. So now we can continue solving, and I'm kind of running out of room, but I can see that if I subtract 12 from both sides and combine my like terms, I have negative 3x equals 0. So x is actually 0. So I'm going to come over here to see my x stands for the cost of a pen. So the pens cost $0. After we find what the pens cost, we can quickly put that back into one of our equations, and I'm going to use this one right here, that first one. 2 times 0 plus y equals 6. So y is 6. Y was the cost of my notebooks, so that must mean that each notebook is $6. Alright, I know this is going long, but I want to show you one other way that you could do this problem. We're first going to write the system again. So 2 pens, remember the pens are x and the notebooks are y. So 2 pens plus the cost of 1 notebook equals 6, and the cost of 1 pen plus 2 notebooks equals 12. So another way you could do this is by the combination elimination. But if we look at our coefficients, they are not opposites right now. So we need to do something to change them into opposites. So I see that I have a 2 and a 1 here. If this was a negative 2, my x's would cancel out. So I'm going to multiply everything by a negative 2. So now I have a new equation, negative 2x minus 4y. Remember the distributive property, negative 2 times x, negative 2 times 2y is negative 4y, and negative 2 times 12 is a negative 24. I'm going to rewrite this equation down here. So I have 2x plus y equals 6. So I just rewrote that first equation, and now I'm going to combine them together. I'm going to add them. I'm going to add them together. Some of you are still thinking it's subtraction, but it's really adding. So what I see in my columns of x's, these are opposites. So negative 2x plus 2x, so this column right here cancels out, so we can just cancel it out. And then negative 4y, this column right here, negative 4y plus y is negative 3y, and negative 24 plus 6 is a negative 18. So when I solve, I see that the y is 6. So I come over here, y is the cost of the notebooks, so each notebook is $6. So again, what we did to be able to combine them is we had to look at one of the equations, I just chose this one, to see what we could multiply it by to get two opposites. So we could combine them and they would cancel out. Now we're going to take that 6 like we have, put it back into one of the equations. So 2x plus 6 equals 6. So I just put the 6 in for y, and once I subtract, 2x equals 0. So a pen, which is my x, is still 0.